Solve the polynomial inequality and graph the solution set on a number line. Now this is a quadratic polynomial, so this is a quadratic inequality. To solve a quadratic inequality, step 1, we solve the equation instead of the inequality. This will give us the boundary values of the intervals that represent the final answer. Graph the solution set on a number line. I will also include the interval notation and the set notation just for practice. Okay, this factors. You can also use the quadratic formula if you choose. You could even complete the square, although this one would be a little messy. 4 times 7 is 28, and minus 7 and minus 4 is minus 11. So we get x equals 7 and x equals 4. Wonderful. The second step is to verify the number line. So 4 and 7. Now this is a polynomial, it's a quadratic, so the graph is a parabola, and it opens up because of the positive x squared. So that's basically the graph. And this is where the x-intercepts are, but because there's no equal sign in our inequality, we won't be able to include those values. Now we're looking for where is it less than 0, so where is it below the axis? That's good. Those aren't good. So our final answer is from 4 to 7. Now for an example, you can also verify these. For example, if I put in 0, I can test that value by plugging it into the inequality. Getting us 28 is less than 0, which is not true, and that X's out all of these numbers in this interval as not being part of our final answer. Testing something in between, this would work, this stuff wouldn't work, and you can verify without the knowledge of which way the parabola opens and the fact that this means below the axis. You can verify this as I showed in previous examples. All right, I hope this helps. That's the interval on a number line. That would be the solution on a number line. In an inequality, that would be the solution as an inequality. And in set notation, that would be the solution in set notation. So all 4 different ways to answer this, just make sure that you understand how to do each one, and whatever you're asked, be able to accomplish that. All right, I hope this helps.